Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, Lesson 8, Graphing the Sine and Cosine Function. So on page 1 of Lesson 8 is a classwork exploratory challenge where you are in your group in a classroom setting and you are asked to graph f of theta equals sine theta degrees and g of theta equals cosine theta degrees. I'm going to skip this because it is a hands-on activity. You need poster board and string or yarn, raw spaghetti, glue. So obviously I can't do all of that in this video unless I did it myself with all those items and videoed it, and I'm not going to do that. So let's move on to the next page. Okay, so page 2 brings us to the exploratory challenge 2. Hopefully you did that other exploratory challenge as a group in a classroom setting, and you use the poster board and the yarn and the spaghetti and the glue, and you figured out these discoveries about the sine and cosine functions. So now we're going to do it in our modules. Part 1, consider the function f of theta equals sine theta degrees. A, complete the following table by using special values you've learned in lesson 4. And then it says to approximate those values 1 decimal place. Okay, so make sure you follow the directions there. They don't want it in radical form. So the first thing I'm going to do is I'm going to draw a unit circle really quick. So here, whoops. So here are the axes. Let me just draw. So here's a unit circle. How about I do the whole thing correctly, right? Let's make this thinner. And then draw a circle centered at the origin. And there's my unit circle, okay? So I'm just going to label the 4 points. This point here is over 1 up 0. This point here is over 0 up 1. And this point here is left 1 up 0. And this one here is over 0 down 1. Okay, and that gives us an idea as to where the 0, 90. So let's do those first. So 0 degrees, we're talking about sine here. So it's the y value, 0 degrees. Sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. And the sine of 270 is negative 1. And 360 is the same as 0, 1 full rotation, and we're back to 0. Okay, so this makes it a little bit easier, I guess. And then if I were to consider the next special values, if I drew a line segment out to 30 degrees, okay, that's less than halfway up. So just when you picture that, you know that the height is less than the distance to the right, and you should know your values now. So the height here is our sine. That's what we're looking for. The sine is either √3/2 or a half, and it is the shorter of the two. So at 30 degrees, we are at 1/2, which equals 0.5. Okay, so I'm going to do it this way. I'm going to show the fraction that we should know and the decimal value. At 45 degrees, we're here. The x and y, or cosine and sine, are equal. That's our square root of 2/2, comma, square root 2/2. So this is going to be the square root of 2. Actually, let me put it over to the left here. This is going to be the square root of 2/2. And I need to know what that is in the calculator. So I bring that up, and √2/2 rounded to 1/10 is 0.7. So I'm going to put 0.7. And then at 60 degrees, we're just flipping that 30, 60, 90 triangle now. Here's 60 degrees. So it's not the half, it's the other. It's the √3 divided by 2. And √3/2 I've done in the calculator already to save time, and it's 0.86. Rounding to 1 decimal place rounds that up to 0.9. Okay, 0.9. Now when we're going over, now picture this, if we're going to go to 120 degrees, there's 90. 120 is 30 degrees more. So now we're here, which would be the same height as the last thing we just did. And now they repeat. So now it's just 0.9 and then 0.7 and then 0.5 and back down to 0. And then when we come around to this side and we get to 210, which is 30 degrees more than 180, where we went left and we went down. Sine is negative in the third and fourth quadrants. So we're now going to get all negative values. So I'll put them here now so I don't forget. These are all negative, second and third, or third and fourth quadrant. So the sine of 210, reference angle 30, is a half, which is 0.5. So all we're doing is this going this way back up to 1, but only negative direction. So 0.5, negative 0.7, negative 0.9, negative 1, and then going back down to, or up to 0, I should say, negative 0.9, negative 0.7, negative 0.5, and back to 0, and we're done. Okay, so hopefully you can do that and picture that in your head. And now we're going to graph these. So the point 0, 0 is right here. 30 degrees, well, this is 45, so it'll be over here a little bit. I'm going to approximate. It's about 2/3 of the way over here. It is 2/3 of the way over, so it's like 2/3, comma, because of my scale here. If this is 90, every line is 45. 45 divided by 3 is 15, and we have 2 15s or 30 degrees, so it's 2/3. Following? So for 30 degrees, we're over 2/3, and we're up a half. So let's make this a half here, and make this 1, and make this down here negative 1. So we're at a half. And then we're going to go to 45 degrees, which is right here on this line, and we're going up to 0.7. That's almost 3/4 of the way up, but not quite. So it's going to be about here. And then we're going to 60 degrees, which is 45 plus 15, which is another 1/3 over. And at 60 degrees, we're at 0.9, which is almost 1, which is about here. And then finally at 90 degrees, we top out at 1. These values are going to become equal. So now we're going to 130 or 120 degrees, which is 90 plus 30, which is 2/3 of the way over. Same height as the last dot before this one. And then we're going to go over to, oh, where are we? Tough to follow with this scale they gave me. 120. 120 degrees, we just did 0.9. 135 is going to be on this line, and it's going to be 0.7. So that's about right here. Maybe a little higher. You get the idea. And then we're going to go over 1 more third to 150, and that's a half, which is right here. And 180 is 0 right there. And then it's going to just repeat on the other side. So after that 180, we're going to 210, which is 30 degrees, which is 2/3 of the way over to 45, and down a half, which is right here. And then 225 is just a 15-degree change to 0.7, which is about here. Maybe a little higher. This is 0.75 here. 0.25, 0.5, 0.75, 0.7 is just below it or above it. Negative 0.9 is at 240. We went from 225 to 240. That's 15 degrees. That's a 1/3 of the way. And we're at 0.9. And then 210, we're at 0. Or I'm sorry, 270, we're at 0. Or negative 1. Hello, negative 1. And then these start to repeat. So this is going to be here. This is going to be here. This will be right here and back to 0. So there is the graph of the sine function with those values. Okay, and then it says, now part C says, extend the graph of the sine function above so that it is graphed on the intervals from negative 180 to 720. So now this is just going to repeat. See how this is 0 and this is 0. So if I'm going to the right, think about the new rotation on the circle. It's going to copy this point here over to here. So now I'll put it in blue over here. And then we're going to be on the line up here. And then we're going to be a third of the way over here. And then we're going to top out at 450. Because 360 plus 90 is 450. So this is equivalent to the 90 degrees, 1. And then these are going to repeat again over on the other side. So this is going to be here. And this point will be about here. This point will be here. And 540 will be back down to 0. And then we're going to go jump to a half. Hang on, it's not over that far. So now we're copying over here. So from 450 is the same as 180. We're going 2/3, and then we're going to be at this level here, 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 -1, coming back up, matching these over here. And ending up at 630. Is that right? No, I'm not over enough. So if I just take all these dots, let me just delete them, Control Z. There we go. Okay, so we're going to end up back at 720, 0 here. Halfway between is going to be -1. And this way I won't make the mistake I just made. So this is going to be here. This is going to be here. Then this, right here, and right here. So there it is. So it starts here, goes up, comes back down to -1, up to 1, down to -1, back up to 0. So there it is, extended to 720. And now I need to go the other way. And so I'll do that in blue as well. So this is going to repeat this pattern, but we're only going to go a half, because at -180 degrees, we're back to 0. So that's going to be 0. Halfway between is -90. That'll be 0, or -1, I mean. And then it's going to copy these distances here. So I'll be about here and here, here and here, here and here. So there it is, coming down, curving, coming back up. Okay, so there's part C. Now for part D, it says, for the interval -180 to 720, describe the values of theta at which the sine function has relative maxima and minima. All right, so the relative maxes and relative minimums are, here's a relative max, here's a relative max, here's a relative minimum, here's a relative min, and here is a relative min. How would you describe those? Okay, so you'd say the relative maxima occur at 90 degrees and 450 degrees. The relative minimum occur at -90, 270, and 630 degrees. E says for the interval -180 to 720, describe the values of theta for which sine function is increasing and decreasing. Okay, so for this, what I'm going to do is increasing, usually we do in green, right? If you're into the stock market, up is green, down is red. So we're going to label this, we're going to draw as neatly as I possibly can. It's really difficult with this pen. All right, so here is where it is increasing until we get to the maximum. So from a minimum to the maximum, going left to right, it increases. That is going to increase again here. And it also increases here. Okay, so those are the values of the sine function where it's increasing, and I'll do the decreasing in red. So here it's coming down, coming down, coming down to our minimum right here. And here it is turning and coming back down, coming down, coming down to the minimum, and then going from the maximum down to the minimum one more time. Okay, so the red intervals are decreasing and the green intervals are increasing. Okay, so it is increasing from -90 to 90. So from -90 to 90 degrees, it was increasing. It was also increasing from 270 to 450, which it says right here, and increasing from 630 to 720. It is decreasing from negative 180 to negative 90, which is right here. Negative 90 to 270, 90 to 270, and then finally decreasing from 450 degrees all the way over to 630 degrees. F says for the interval negative 180 to 720, list the values of theta at which the graph of the sine function crosses the horizontal axes. Okay, so it crosses at negative 180, 0, 180, 360, 540, and 720. Okay, so there are those values that I just listed as we were going across and seeing where they cross the x-axis. All right, page 3 brings us to part G, and it says to describe the end behavior of the sine function. So if I go back to this, what's the end behavior doing? Well, does this ever end? If we keep rotating around in circles, isn't this going to just continue going up and down and 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 up and down, and I'll stop now. There, the sine function will continue to what is called oscillate between negative 1 and 1 as theta goes to infinity, or as theta goes to negative infinity. It's just going to keep going between 1 and negative 1. H, based on the graph, is sine an odd function, even function, or neither? How do you know? Okay, so an odd function means that if you plug in a negative value for x, so if you take f of negative x, it will equal the negative of the function. If it is even, if I plug in a negative x value, f of negative x will equal f of positive x is even. So in other words, odd functions are going to reflect around the origin. An odd function will also reflect around the origin, and that's what you could write here. So I'm going to put that. Sine is an odd function because the graph is symmetric with respect to the origin. I says, describe how the sine function repeats. Okay, the sine function repeats the same pattern on every interval of length 360 because 360 degrees is one full turn. After that, the values of sine just to continue to repeat. All right. So it repeats every rotation of the circle. So now we're going to do part 2, which is going to consider g of theta equaling cosine of theta degrees. So we're going to complete the following table in the graph. And so it is very similar to the sine function. We're going to get the same values, just in different degree measures. So the cosine of 0 is over 1 up 0. Cosine, remember if I had that unit circle, let me bring that in again. Okay, so here we go. I brought this unit circle in down here just to give us an idea as to where we are. And so using the values, complete the table, 1 decimal place again. So the cosine of 0, remember if we are here, 0 degrees is right here. That's the 0.10. Cosine's the x value, that is 1. Cosine of 0 is 1. Okay. Cosine of 30 degrees is going to be not the half, but the root 3 over 2. And I will go to my calculator again. Square root of 3 over 2 is 0.86 or 0.9. 45 degrees is root 2 over 2, right? It's halfway. So if I move this up over to here, it's equivalent to the y value at that location. It's root 2 over 2, comma, root 2 over 2, and root 2 over 2 is 0.7. So 0.7. 60 degrees would move this to here, and that would be not the root 3 over 2, but the half. So that's 0.5. And then at 90 degrees, cosine is the x value, that's 0. Okay, at 180, it's negative 1. At 270, it's 0 again. And 360 is equal to 0, which is 1. So those are those values. And then these just repeat in between. So, but be careful, cosine is negative where? Quadrant 2 and 3. So we are in quadrant 2 here, so it's going to be negative 0.5, negative 0.7, negative 0.9, negative 0.9, negative 0.7, negative 0.5. And then we're going positive now in the fourth quadrant. We're going to the right again. So that's going to be a positive 0.5, a positive 0.7, a positive 0.9, and back up to 1. Now they want us to graph it. So using the values in the table, sketch the graph of the cosine function on the intervals from 0 to 360, which is from here to here. So starting at 0, we are up at 1. So if this is a half right here, 1 is right here. I'll graph the easier ones first. 90 is 0 right here. 180 is -1, which is right here. 270 is back to 0. And 360, we're back up to 1. So as you can see, this is going to look like the sine function just shifted 180 degrees to the right or left. Okay, so now cosine of theta, cosine of 30 degrees is 0.9. So if this is 45, 30 is 15 less right here. 0.9 would be way up here. 0.7, this is 0.75, so 0.7 would be a little bit lower. That's at 45, that's right here. And 60 degrees is 15 more degrees. So I'm 1/3 of the way from that middle, and that's going to be a half. So I'm going to come over here, half, back up, like, no, I'm sorry, I don't know what I'm doing. Got to continue south. So now this is going to be -1/2. So where are we? We're right here, 120 degrees. That is 45 degrees past 90, which is here, 120. So this is going to be, where am I? 120, -1/2, which is right here. And then we're going to, did I do this right? I just want to make sure I'm doing this correctly. So 45 degrees is here, and another 15 is here, and then 90. And then 120 is 30 more degrees, not 45. So I'm not on that line. That's where I was off. It's 2/3 of the way over, add a half. There we go. And then 135 is 45 more than 90. So we're right on this line, -0.7. And -0.9 will be 2/3 of the way over this way, or 1/3 more, 0.9 right there. So it's curving, coming down to -1. Now it's going to turn and go back up, but it's going to repeat. And now we're going to have this value, this value, this value, and then back to 0. And now this repeats over here, which is, let's see, 2/3 of the way past 270, which would be about here. This would be on the line right here, and then coming up right about there. So there is the cosine curve, like so. This dot right here just needs to be moved. Ooh, they're all connected. Great. Let me erase this one. I went 2/3 over. It's only supposed to be 1/3. That should be more like right there. Okay, so there is my cosine function curving, starting at 1, going down to 0, coming back up to 1. Okay, so that's B. Part C says to extend the graph of the cosine function to -180 and 270. So this, I'll go to -180 first. This is just going to repeat over to this side. This is going to repeat over to this side and continue the repeat. And back down to 90 is 0. And continue to about here, 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 and finally back down to 0 there. So as you can see, it's going to repeat, and we're going to repeat over here as well. So this would be equal here. Same level here, same level here, coming down to 450 at 0. And continuing there, there, about there, there, here, here. How about here? 630, we're back to 0. Now we're repeating over here. And there it is. So it started here, curved up, back down, up, back down, up. All right, there's part C. Okay, so part D, what page are we on? We're on page 4. Part D says for the interval from negative 180 to 270, describe the value of theta at which the cosine function has a relative maxima and minima. So if I go back, I'll have to keep going back and forth here, unfortunately. Actually, no, I won't. I'm going to bring this over. Okay, this is better. Here we go. All righty then. For the interval negative 180 to 270. Okay. Did they mean 720? Part D. The reason I'm wondering is, did they say 270 or 720 in the prior problem? Yeah, it's a misprint. See that 720, 720, 720. They're doing the full interval. All right. So riddled, misprint. This should be 720. We could have done it to 270, but they mean the whole interval. So the values of theta where the cosine function has a relative max and min. So minimum, 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 maximum, maximum, maximum. Okay. Okay, so the maximum occur at 0, 360, 720. The minimums occurred at negative 180, 180, and 540. So there they are. Now it says for the interval, describe the values of theta for which cosine function is increasing and decreasing. So I will use green for going up. Okay, I did click on green. You can see that, right? So this is green coming up. Here's the interval where it is increasing. Here is another interval where it is increasing. And here is another interval where it is going up from left to right. It is decreasing from that maximum to the right, down to that minimum. From this maximum to the right, down to this minimum. And that's that. Okay, so the intervals of increase and decreasing are, okay, increasing from negative 180 right here to 0. Increasing from 180 degrees to 360 degrees. Increasing from the x value 540 degrees all the way up to the x value 720 degrees. Decreasing from 0 to 180, decreasing from 360 to 540. For the interval, list the values of theta for which the graph of the cosine function crosses the horizontal. Okay, well, the horizontal is, it's crossing at negative 90, 90, 270, 450, 630. Those are where it is crossing the x-axis. Okay, so there are those values written down. G says describe the end behavior of the graph of the cosine function. Well, it's the same as the sine. It's going to keep going up and down and up and down and up and down from negative 1 to 1 forever and ever and ever. So we would say the cosine function will continue to oscillate between negative 1 and 1 as theta goes to infinity or as theta goes to negative infinity. And H says based on the graph, is cosine an odd function, even function, or neither? How do you know? Well, I do know it's not an odd function because it does not reflect across the origin. It is reflecting, it's shifted up or to the right and it's not reflected across the origin. If it were reflected across the origin, this point here would reflect to this point right here, and it obviously does not. So it is not an odd function. Is it even? Okay, so the cosine is an even function because the graph is symmetric with respect to the vertical axis. So we reflect it across the y-axis, it's even. We reflect it across the origin, it is odd. I describe how the cosine function repeats. Okay, the cosine function repeats the same pattern as intervals of length 360 because 360 degrees is one full turn. After that, the values of cosine just continue to repeat. Okay, finally, part J, how are the sine function and cosine function related to each other? Okay, so the two functions have the same maximum, they have the same minimum, and they have the same values in between those maximum and minimums, except they have the same y values, but not x values. So the two functions are horizontal translations of each other. We could shift the graph of either function horizontally to line up with the graph of the other function. And how far would we have to shift it? Well, if the sine function starts at 0 and this 90 degrees is at 0, I would have to shift it left or right 90 degrees to get the cosine function or sine function to land on the other. Okay, page 5 brings us to the end of lesson 8. Review the lesson summary and go to your problem set.